Hi, Assalamualaikum warahmatullahi wabarakatuh. In this video, I would like to talk about two examples related to finding the basis. So the first example will be about finding the basis for the column space of matrix A. And the second example is about finding the basis for the null space of matrix A. Right, so let's jump straight to the first example here. You are asked to find a basis for the column space of this given matrix. Now the process to find the basis for the column space is quite simple. Really, it is something like this. Let's say you have matrix A, and then you are going to apply what we call the elementary row operations so that you can reduce this matrix to this form. So here is the reduced row echelon form, and based on this reduced matrix, you need to be able to identify which column has leading 1. So that is what you need to do. So once you have managed to identify that, you are going back to this matrix again and consider the same column as what you have done at this part here. So first you identify the column which has leading 1 from this reduced matrix, and then you go back to the original matrix A to consider the same column that you have found right here. And by doing that, the column of that from the matrix A here is the basis for column space. So that's the idea. Okay, that's how you can find the basis for the column space. Well, without further ado, let's just try and apply the process given here. So here we have this matrix A. Okay, so I'm just going to consider the process straight away. So this is matrix A. What I need to do is, I need to make sure this becomes 0. So I'm going to apply the process R2 plus negative 2R1, and therefore it becomes 1, 1, 1, 3, 1, 6. So for the second row, it will be 2 minus 2, 0, negative 1, minus 2, negative 3, 0, minus 6, 1, minus 2, negative 1, negative 1, negative 12, negative 13. So here we have 0, negative 3, negative 6, negative 1, negative 13. Next, of course, we need to consider changing this to 0 as well. So we're going to do the process right on the same stage right here. So we have R3 plus 3R1. So negative 3 plus 3 is 0. 2 plus 3 is 5. 1 plus 9 is 10. Negative 2 plus 3 is 1. 1 plus 18 is 19. So that's the result for the third row. And finally, also this part has to be equal to 0 as well. So again, we're going to consider the process here on the same stage. So we have R4 plus negative 4 R1. So 4 minus 4 is 0. 1 minus 4, negative 3. 6 minus 12, negative 6. Well, 1 minus 4, negative 3. 3 minus 12, negative 9. Yeah. Okay, so sorry, 3 minus 12, 3 minus 24, so negative 21. Okay, I'm sorry for that. Okay, negative 21. Okay, so next what we can do is, well, I can consider this part here and turn it into value of 1. Okay, so because it has quite nice combination of numbers, you can see when you divide it with 3, it's easy to divide everything here with 3. You know, compared to this one, we have negative 13 over 3, which is not really nice, I think, in terms of the representation of that number given. So we can perhaps choose this fourth row, and we're going to turn it into the value of 1 right here. So you can do that, you can consider that. So negative 1 over 3 times the fourth row. So we're going to do changes on the fourth row, and therefore the result that we have here is 1, 1, 3, 1, 6, 0, negative 3, negative 6, negative 1, negative 13, 0, 5, 10, 1, 19. So here it will be 0, 1, 6 over 3 is 2, 3 over 3 is 1, 21 over 3 is 7. So that's the result that we get. And of course, you can see that since we have the value of 1 here, we can change the position of this fourth row and the second row. Okay, so that's what I'm going to do. I'm going to consider switching the fourth row with the second row. So the result is given here. So what's the result? It will be 1316. 11316. 0, negative 3, negative 6, negative 1, negative 13, and then 0, 5, 10, 119, 0, 5, 10, 119. Oh, sorry, I have to switch the row, yeah? So I'm going to switch the row, sorry. Let me just erase that, switching the row right now. So here it will be 01217, 01217, and at the bottom is 0, negative 2, negative 6, negative 1, negative 6, negative 1, negative 13. Okay, so that's the result. Next, what we can do is we can consider changing this value to 0. So it will be the third row plus negative 5 multiplied with the second row, and the result is going to be 11316, 01217, and here it will be 0 minus 0, 5 minus 5, 10 minus 10, 1 minus 5, negative 4, 19 minus 35. So that is negative 16. Okay, so that's it. And also we need to consider changing this value to 0. So the fourth row plus 3 times the second row. So 0 minus 0 plus 0 is 0. Negative 3 plus 3, 0. Negative 6 plus 6 is 0. Well, negative 1 plus 3. So here we've got negative 1 plus 3 is 2. Negative 13 plus 21. So that will be 8. Okay, 21, 13, yeah, 8. Okay. Well, next is, of course, I can consider changing this value to 1. So here that can be obtained if you consider multiplying with negative 1 over 4. with the third row. So the result that we have is here we will have 0, 0, 0, 1, and here we will have the value of 4. And at the bottom is 0, 0, 0, 2, and 8. Okay, next what we can do is we can consider, well, taking this value equals to 0. So what we can do is going to make the change on the fourth row plus -2 times with the third row. So here we will have 1, 1, 3, 1, 6, 0, 1, 2, 1, 7, 0, 0, 0, 1, 4, and here will be 0, 0, 0. Well, 2 minus 2 is 0, 8 minus 8 is also 0. And we're not done yet because we need to show that the matrix here is in RREF form. So we are going to continue the process here. Well, we can then consider making sure the value here is 0. So what we can do is we can consider R1 plus -1 R2. So we will have the result is, well, 1 minus 0 is 1. 1 minus 1 is 0. So 3 minus 2 is 1. 1 minus 1 is 0. 6 minus 7 is -1. Okay, so 0, 1, 2, 1, 7, 0, 0, 0, 1, 4, 0, 0, 0, 0, 0. So now this part here looks alright. For the first column here, we have the leading one here. The rest are all 0. This also looks alright. We have leading one at this position. The rest are all 0. So here is another leading one that we need to consider. And therefore, we have to turn the value here into 0 as well. So we're going to make changes on the second row plus -1 of the third row. Okay, so the result is going to be 1, 0, 1, 0, -1. Well, for the second row, it will be 0 minus 0 is 0, 1 minus 0 is 1, 2 minus 0 is 2, 1 minus 1 is 0, 7 minus 4 is 3. The third row is 0, 0, 0, 1, 4, 0, 0, 0, 0, 0. Now this is already in RREF. It is already in RREF form. Okay, so reduced row echelon form. And you can see this is the position of leading one. So this is the first column. This is the second column. We have leading one right here. And then this is the fourth column. So we have column 1, column 2, and column 4. So we go back to the original matrix. So here is original matrix, matrix A, and we are going to consider that same column. So we have arrived at this stage here. We're going to consider the same column in matrix A, which is this column. Oh, hang on. So we're going to consider this column here, column 1, and then we're also going to consider column 2 and column 4. So column 2 and column 4. Okay, well, I'm just going to continue my work right here. So therefore what we can say now is that hang on, let me just erase everything here. Okay, So based on that, we can say that basis of the column space is, so here we say basis for the column space of matrix A is just equal to, here is the first column, 1 2 -3 4, and then we're going to consider the second column, 1 -1 2 and 1, and finally the last one, sorry, not the last one, the fourth column is this one, 1 2 3 4, so this one. Okay, so here we will have 1 1 -2 1. Okay, right, so that's the answer for example 3.35 done. Now let's move on to the next example here, where it is asked where it is asking you to find the basis for the null space of matrix A. Okay, so how do we find the basis for the null space? The process can be described as such. Well, we have matrix A. Again, we have to reduce this matrix using elementary row operations. So the matrix here is in this form. So here RREF. And then based on the matrix that you get here, you're going to consider the process of, well, for simplicity, we can call the result of this matrix as R. Okay, so now we can consider this matrix with the unknown variables x must be equal to 0. So here we are going back to the idea of solving a system of linear equations, a homogeneous system of linear equations. And this is something which you have already seen in the previous video when I talk about the idea of null space. So once you consider this homogeneous system of linear equations, you're going to solve for the unknown x. So here is unknown x, and you're going to get what the solution of that unknown variable. So here we are going to get the solutions. So these solutions here becomes the basis for null space. Okay, so that's the idea. It is quite simple. Now notice that the matrix given here is the same matrix which you have seen in this example here. So we are just going to skip the process of doing ERO. We don't need to do this because we already have got the result. Yeah, so we're just going to continue the process from this point onwards. Okay, well, the matrix given is let me just write down what's the matrix. RREF here is, well, 1 0 1 0 -1. This is RREF, and then 0 1 2 0 3. Okay, and then we will have 0 0 0 1 4, 0 0 0 1 4, and finally it's just all zeros. So this is already in RREF form, so we have arrived at this stage already. Yeah, so we will consider this matrix here as R. So it will be multiplied with the unknown x, and here is 4 by 5 matrix, four rows and 5 columns. Therefore this one here must be 5 by 1 matrix. So we know that we shall have x1, x2, x3, x4 and x5 to be considered. Okay, and on this part here we are going to have 4 by 1 matrix, which means we have 1 0, second, third, fourth 0. So that is the homogeneous system of linear equations that you have to consider. And in order to solve for the unknown variables of x, we can apply the usual process, which is, turning it into the augmented matrix. So the augmented matrix will look like this. We have 0, 1, 0, 1, 0, negative 1, and then 0, 1 to 0, 3. And then we have 0, 0, 0, 1, 4. And everything here is 0. And right here is 0, 0, 0, 0. Now, we don't need to do anything about it because really we have actually simplified the whole process, and we can just consider perhaps this line and consider what's the equation related to that. So here we will have basically 0 times x1 plus 0 times x2 plus 0 times x3 plus 1 times x4 plus 4 times x5 is equal to 0. So 0, 0, 0 can be cancelled out. x4 is equal to negative 4x5. So this is the first equation that you can consider. Next is this part here, which means you have, well, 0x1 is 0. So here I have x2, 1 times x2 plus 2x3. I'm just skipping this long part here. I'm just going to consider it straight away. So here we have 1x2, 2x3, and 3x5 is equal to 0. So x2 is equal to negative 2x3 minus 3x5. Yeah. So this is the second equation. And finally, this last part here corresponds to having x1 plus x3 minus x5 is equal to 0. So x1 is negative x3 plus x5. Now notice that you have 3 equations, but you have 5 unknown variables that you need to solve. Therefore, we know that 2 of them are going to be free variables. So we're going to let x4 and x5 be the free variables. So we can say that let's set x5 equals to s, where s is any real number, and x4 is equal to so first of all, it can be not x4 and x5 directly. Sorry, let me just erase it. So first of all, we can consider we can view it by considering one by one of the equation given here. So first of all, x4 here is given equal to negative 4x5. Therefore, we can set x5 to be equal to s, yeah? And in this case, x4 is just negative 4s. So that's the value of x4 based on this part of the equation. Next, x2 has something to do with x3 and x5. And so far, we already set x5 to be the free variable. So x5 here is the free variable. Now, based on this equation, we can also set x3 to be the free variable. Okay, we need 2 free variables, yeah? And we're going to say, let's set x3 equals to t, and that t is also a real number. So based on that, x2 is negative 2 t negative 3s. So that is x2. And finally x1 is equal to negative x3. So negative x3 is x3 is t, so negative t. plus x5. x5 is s, so negative t plus s. Okay, right, so here are the solutions, and we're just going to write the solutions nicely in this format. Okay, so let me just erase this part. Okay, so based on the solutions given here, we can then go on and consider writing the solutions in terms of this notation. Using this notation, we have x1, x2, x3, x4, and x5. And this is equal to, well, x1 is negative t plus s, x2 is negative 2t minus 3s, x3 is equals to t, x4 negative 4s, x5 is s. And here we recognize there are two components related to t and s, and we can separate them. Okay, so it will be looking like this. So negative t plus s, and you can see when you add these two components, negative t plus s, this is the result that you will get. So here we will have negative 2t minus 3s. So here we have t, but no component of s. That means the component of s here is 0. You can see that t plus 0, the result here is t. And for this one, negative 4s, no component of t. So this part here is 0. This is negative 4s. So here we have s, no t. Again, this is 0, and this is s. Also, we can transform this look here to include only numbers in the matrix notation. So we can take out, for example, t to be taken outside. So here we have t multiplied with a matrix with just numbers in it. So we have negative 1, negative 2, 1, 0, 0. Okay, so notice when you multiply t with negative 1, you will get negative t. T negative 2, you get negative 2t, and so on. Okay, so with a similar idea, we're going to consider taking out s and leave all the numbers in the matrix. So here we have 1, negative 3, 0, negative 4, 1. Well, based on the numbers that we have here, we can then conclude that therefore basis for null space of A is going to be equal to the combination of these two matrices here. So we have negative 1, negative 2, 1, 0, 0, and 1, negative 3, 0, negative 4, 1. Okay. So I think that's the end of this video, and I'll see you in the next one with more examples related to finding the basis. Thank you very much for watching.